By providing us with heat and light, the sun plays a key role in the survival of life on Earth so that it may appear as a special and unique star in the universe. But the fact is that the sun is just an ordinary star. But since it is located so close to us, we scrutinized it in great detail. The sun orbits once every 24.5 days and has a diameter of 1.39 million kilometers. This star is a melting furnace of a large nucleus in which atoms combine to release huge amounts of light and heat. The surface we see from the sun has a temperature of about 5,500 degrees Celsius and is part of a burning, turbulent potion created by a mixture of charged particles and magnetic fields. Almost everything we see on the sun is a state of matter called plasma, in which gases are separated into negatively charged electrons and positive ions. The sun has an active cycle with an intermittent period of about 11 years, during which the number of sunspots, flares, and eruptions increases and decreases significantly. Solar winds. A stream of charged particles called a solar wind is constantly being launched from the sun at a speed of hundreds of kilometers per second. The solar wind creates a huge bubble in space called the heliosphere, which protects the Earth and other planets from interstellar space. The solar wind, like the Earth's atmosphere, has variable conditions. Solar winds can be stormy, and their effects on planets and comets can change abruptly. The Earth's magnetic field protects the planet and its creatures from the sun. This magnetic bubble, called the magnetosphere, causes solar winds to usually hit the Earth just near the poles, exhibiting aurora borealis. This is exactly what happens to Saturn. Saturn, like Earth and many other planets, has a magnetic field. In an aurora borealis phenomenon, the interaction between the solar wind and the planet's magnetic field forms aurorae around Saturn's poles. Ultraviolet light emits light near Saturn's south pole. Surface effects. The magnetic field controls almost everything we see on the surface of the sun. Large-scale dark spots in hot plasma are signs of sun corona cavities, which are the source of most solar winds. A magnetic field escapes into space with the solar wind in these holes. Brighter spots represent the highly compact and intricate magnetic field lines that trap hot plasma and are known as active areas. These areas are usually located on sunspots. When the active area erupts, it turns into a solar flare that glows at full wavelengths for minutes or even longer. Sunspots. Although these dark areas are cooler than their surroundings, they still have incredibly high temperatures. These spots show places on the surface of the sun where part of the sun's inner magnetic field protrudes from the star's surface. Massive solar eruptions. It is a massive eruption that launches plasma into space. These eruptions occur in various dimensions and velocities, some of which can have dramatic effects on the Earth's magnetism. The sun in ultraviolet light. Observing the sun at different wavelengths can detect parts associated with different temperatures. This ultraviolet image of the sun shows matter at 60,000 degrees Celsius, which is 10 times hotter than the visible surface of the sun. The structures you see are far larger than those seen in visible light. The bright areas are related to desirable and dense plasma, and the darker and cooler areas, called filaments, float above the sun's surface with the help of a magnetic field. Now let's take a look at the moon. Be with us until the end. Month. Earth is the only planet in the solar system whose moon is comparable in size to its parent planet. The moon was likely formed when a large body the size of Mars hit the young Earth. In this collision, masses of matter were launched into space, eventually merging to form a moon for Earth. The moon's orbit gradually became farther and farther away, so today, the moon orbits the Earth once every 27.3 days. In the distant past, the inside of the moon was so hot that many volcanic eruptions occurred on its surface. But these activities have stopped for years. Surface effects of the moon. Countless collisions that have taken place over billions of years have filled the lunar surface with lows and highs. A large part of the moon is covered with craters of different sizes. From the point of view of the naked eye of the terrestrial observer, the most characteristic feature of the lunar surface are dark spots. These areas, called the sea, are formed when liquid lava fills large impact craters. These massive volcanic eruptions stopped about 1 billion years ago. The moon is the cause of the tides in the seas of the Earth. The moon draws water to itself. As a result, it creates a bulge on one side of the ground. Another bulge forms on the opposite side of the Earth, where the moon's gravity reaches its weakest point. The moon's presence has also helped keep the Earth's axis of rotation stable. A phenomenon that, in turn, plays an important role in the formation and evolution of life. Crescents of the moon. The moon shows different crescents as it orbits the Earth. The moon's orbit is not circular, and the distance between the Earth and the moon varies from 362,600 kilometers to 405,400 kilometers. The time it takes for the moon to orbit itself is equal to the time it takes to orbit the Earth once. This phenomenon, known as coordinated rotation, means that a hemisphere of the moon always faces the Earth. Between 1969 and 1972, 12 astronauts landed on the moon during 6 Apollo missions. Their activities and studying soil and rock samples that these astronauts brought to Earth changed the knowledge of the study of the moon.